So students, welcome back to our channel. And today's video we are gonna be continuing our class 12 series. This video is gonna be the second part of ITF trigonometric function. First, in the previous video, I give you a brief introduction about what are inverse trigonometric functions and what is the range and domain, all this stuff, and how inverse sine function works, and what is its domain and its range, and what is the general form of its output, all the stuff. Today I'm going to be talking about inverse cos function, cos inverse function. Okay, so if you have watched the previous video, then this one is going to be a lot easier for you to understand, because of course these two are connected. So what is the cos inverse function? Cos inverse function, as the name suggests, it's the inverse function of the cosine function. So what is the cosine function? Cosine function is a trigonometric function that takes an angle as an input and gives us a specific ratio for that angle. Let's say we have a right angle triangle here, with one of its triangle being with one of its angles being theta, and the corners are A, B, and C. So cos of theta, cosine function of theta, which is an angle, would give us the output of the height over the hypotenuse of the triangle with respect to this angle. So from the perspective of this angle, the height is AC, the hypotenuse is AB. This is gonna be the output of the cosine function. Let's say if the value of theta is 60 degrees. In this case, this output's value is 1/2. Now, what does a cosine function, inverse function do? Of course, as like we have learned in the previous video, as sine inverse takes inputs which are outputs of the sine function, and basically values for specific ratios of the angle that it has been given as input, and it spits out that angle. Same with cosine inverse function as well. Let's say we have a cos inverse function applied onto this ratio AC over AB. So in this case, we will get theta, because theta is the value of the angle that has been the variable that this cos function has been applied onto to get this ratio. Okay. From here, if we apply the cos inverse function on this value 1/2, we would get 60 degrees, because 60 degrees is the value of the angle on which this cosine function has been applied to, so that it gives us 1/2 as output. The only problem is that this is not completely true. As I told you guys in the previous video, that the first two trigonometric functions, sine and cosine, are cyclic function. That means their value, their output just keeps on showing up again and again in a cyclic format. The graph of the cosine function looks something like this. The value begins from the value of the output begins from -1 and 1, and it hits the lowest value of -1, and these two values keep showing up in a 2 pi radians or 360 degree interval. So this means that there are multiple values of theta for which the output of the cosine function is also AB over AC, and there are multiple values of this particular angle for which the output of the cosine function is going to be 1 over 2. So just saying that if cos theta is, if just saying that if cos theta is 1 over 2 and theta is 60 degrees, this is not completely satisfied, because there are also like infinite number of other possible values of theta for which the output of this cos theta function is also going to be 1 over 2. Okay, so how do we show that? In the previous video when I was teaching about sine inverse function, I probably forgot to do this thing. That was I just told you how to how this thing was actually expressed and how to memorize that. But I think a better way to teach this would be help you visualize this. Let's do let's do it for the cos function. Let's say on this point we have a value up to the function. On the x-axis we represent the value of x, of course, the inputs of the cos function, and on the y-axis we are going to represent the value of the cos theta function. Okay, so let's say on this point we have a value y, and this value would keep showing up after a certain interval. Now, what is that interval? That interval is gonna be the general form of the output of the cos inverse function is gonna be 2n pi plus minus alpha. Alpha is the value. Alpha is the prime value. I'm coming to that later. But let's say if cos theta, or cos alpha is a value, let's say y, then cos inverse of y is gonna be 2n pi plus minus alpha, where n is a natural number, is an integer. Now you might think that why the hell does this formula look like that? You just need to visualize that. Let's say for first time the value of n is 0, so this would like 2 times 0 times pi is going to be 0 times pi, so that is going to be 0, which is going to be our starting point, and next it says plus minus alpha. Let's say this much is plus alpha and this much is minus alpha. Of course, the distance of the x is for x values of the distance of the x values, of course, going to be same, and for that the output is also going to be the same. Let's say there is another value of alpha. Let's say alpha 2, for which we get an output y2. You can say that regardless if we add or subtract alpha from this value, we're gonna get the same output, because this is what the graph tells us. Let's say in the third case the value of n is 1, so we would the first one would be 2 pi, so it would end up here from this point, and from then on if we go on either sides equal distance, then the value of output we're gonna get is gonna be the same. Let's say if this is d, and this 2 has to be d. Okay, this is why this output, the output of the cos inverse function is gonna look like this. There are numerous values of alpha for which this uh, this expression is correct, for which cos of alpha is gonna be y. This is how this thing works. Now let's talk about prime value. In the previous video as well, uh, I told you that what is the prime value of a cos inverse function. Prime value is the bare minimum range in which all the possible values are all the possible values can be found. And also told you guys that, I don't know if I told you guys about this in the previous video or not, but the range of prime values is always gonna be, at least for the first two trigonometric functions, it's gonna be a range of pi radians or 180 degrees. For cosine, for sine function, it ranges from negative. Uh, I think it ranges from, the sine function looks something like this. And for that, it ranges from negative pi over 2, negative pi by 2 to positive pi by 2. From this point to this point, this is negative pi by 2. This is negative pi by 2. And this is positive pi by 2. And in this range, all the possible values of sine function, sine theta function are covered. Now, for the reason we say that the prime value of sine function ranges in this range, because let's say if you had started from point 0, if you had started from point 0 and went to right side only, then on that case, we would have only gotten values from 0 to 1 twice. If here's value, the output is going to be 0, here it's going to be 1, and this we are going to be finding everything in between. And here as well, this value is going to be 1, and this value is going to be 0. And we're going to be in this range, we're going to be finding out everything in between. So these values are same values are going to show up twice. So that is not going to be efficient. But for cosine function, that is not true. It begins from positive 1, the output value, and when it hits positive 180 degrees or positive pi radians, its value hits its lowest possible value, which is -1. And in this range, all the possible outcomes, all the possible outputs of the cos theta function are covered. That is why the prime value of cos inverse of x ranges from 0 to pi by 2, from 0 to pi radians. Okay. And another thing that has to be mentioned here is that the range and domain and range for this function as well is going to be same as the sine function, because these two functions are pretty much the same. The only difference is the phase difference between the two. I'm not going to be going into that right now. I will definitely talk about that later in maybe another video, but both are cyclic functions, and both have highest values 1 and lowest possible values -1. So when you are trying to get an inverse function of that, the value of the domain, basically which is a set of values, the inverse function of that can take as inputs, always has to range from -1 cos inverse domain belongs to a set of -1 to +1 and everything in between. Okay. And now what is the range? The range, of course, the cos function as well can take any number of like any value of angle as input. So uh, the output of the cos inverse function, which is gonna be the range. Of course, it's gonna range from negative infinity. Of course, we have first bracket here because infinity is not a real number. We can never actually approach it. It is gonna range from negative infinity to positive infinity. Is that clear? This is where I'm gonna wrap this session up. If you guys think that you have any doubts regarding anything I have taught you guys today, do let me know about that in the comment section, and I'll try to help you figure that out. If you thought that this video deserves appreciation, then make sure to like this video. Then make sure to leave a comment, and make sure to subscribe to my channel, so that these kinds of videos can be shown to your feed again and again. And until the next time, keep learning.